Hi, everyone. Thanks for coming. I hope everyone's well caffeinated after the break. My name is Mike. I'm from Bulgaria, but I currently live now in what seems to be sunny Amsterdam, which is pretty special for us. Here you can see some random facts about me, the most important of which is probably my Twitter handle, which you can use to reach out during or after the talk if you have any questions. I'm currently a software engineer within an operations team at Bo.com, which in essence means that I get to break a lot more things than the average engineer in the company. And recently, Bo.com had to deal with a large application we classified as a beast. And today, I'd like to share with you our journey from turning that beast into a pet. Here's a quick overview of the talk that I'm going to give today. I'd like to give you some perspective about the company for those that are not familiar with Bo.com. I'll tell you what our definition of done is. Sorry, definition of done. What our definition of beast is. After that, I'd like to share with you what options we had to deal with that beast and why we chose the one we chose. And finally, I'll share some of our wins, some of the mistakes that we made along the way, and overall, what are the lessons that we learned. So for everyone that's not Dutch, let me give you some context about the company. Bo.com is the largest online retailer in the Netherlands. It was founded back in 1999 and has been growing ever since. Currently, it employs more than 1,500 people, out of which around 400 are comprising the IT department. And back when the company was founded, things were relatively simple. There was one application and it had its one deployment. As time went by, that release process became a little bit more streamlined, and the deployments were scheduled once every 4 weeks. But as the application grew, that soon became a little bit hard to manage. And as many companies back then, Bo.com adopted service-oriented architecture and started splitting that large application into smaller independent services. However, there was still one big deployable unit released once every 4 weeks. Later, Bo.com enabled teams to deploy their services independently, setting the grounds for an autonomous and agile environment. And things were good. People were happy. Engineers were happy. Stakeholders were happy. Everyone was happy. So how did the company end up in a state where anything needs taming? Well, unfortunately, some of the applications were still stuck in the past, mostly because of their size and their nature. And one of those applications is the Bo.com webshop, which is essentially the money-making machine of the company. The only improvement that it had seen release-wise in the past years was that it was now deployed once every 2 weeks instead of the previous 4 week cycle. Now, if you're wondering why a company that embraces agile principles would keep its most valuable application in a not so agile state, it was because that application was a beast back then. Our definition of a beast is a big application which is actively developed by a lot of people but managed by no one, and has parts only known to few or none. And of course, this is an over-exaggeration, but we really wanted to make a point when we started this. Because the web shop was a large monolith. Its layers were so entangled that it was really hard to decouple them. And on top of that, it was built on top of a framework which was not designed for the scale that we currently have. And that required a lot of hacks which were not necessarily very well documented and very well tested, effectively rendering it a legacy system. And finally, it was simply unmanageable. Not because people didn't want to invest the time into managing it, but simply because it was not possible with the tooling that we had back then. We had over 70 engineers working on this, and in a span of 30 days, we had more than 900 commits to this project. And any single person that tried to manage it on their own felt like this, and eventually just gave up. And don't get me wrong, over the past years, people have been actively working on breaking down that monolith. Parts of it were extracted into separate services, and people are trying to break it. However, that slow release cycle that we had wasn't giving us the feedback that we need. The feedback loop was too long, and that made the whole process really tedious and not as rewarding as everyone wanted. So we had our beast, and we had to deal with it. The first obvious choice was to kill it altogether. I mean, everyone's slaying monoliths nowadays, right? But we quickly realized that this is not a feasible path for us because the application was so large that it would require a lot of time and effort to rebuild it. On top of that, Bo.com, the web shop is the center of Bo.com's business, meaning that if you want to replace it with a new system, you would have to add new functionality to both the new and the old system until the new one is ready, effectively making this shooting at a moving target. Now, we figured that we cannot kill it, so we decided to tame it. How? The answer for us was through being able to change it at a fast and stable pace. We had the people, we had the expertise, and we had the knowledge on how to deal with the monolith, but what we didn't have is that short feedback cycle on all the changes that we're making. We needed to make sure that all the changes that we're doing are going live as soon as possible. Essentially, what we needed was continuous delivery. And it felt like a natural next step for the project because most of the projects at Bo.com are actually implementing continuous delivery in their life cycle. But because we had experience with continuous delivery, we also knew that that can be really hard to achieve, especially on a large-scale project. Before I go any further, I'd like to point out that by continuous delivery, I'm referring to the term of Martin Fowler, which is different than continuous deployment, but people often mistake the two. The main difference is that continuous deployment requires automatic deployments to production. So the only thing that you as an engineer would do is just push your code to the source control, and throughout the lifecycle of the application, it will go to production. Whereas with continuous delivery, that final step of deploying to production is still scheduled manually. Now, we knew that we wanted to achieve continuous delivery for this project, but we didn't really know what's preventing us from doing it. And I don't know about you, but back then, most of the articles that I found on the internet about continuous delivery in particular were about how to implement it. No one really described any problems that you might have with continuous delivery. So I did what probably everyone would do when you don't know anything, when you don't know something, pardon. And I asked Google about problems with CD. And I really hope that all of you know what a compact disc is, because then I would feel really old. But I refined my search a little bit, and I found an awesome paper which describes problems when adopting continuous delivery. It also makes suggestions on how to solve those problems. And if you're planning to adopt continuous delivery, I would highly recommend that you spend the time to read this paper because it can save you a lot of time. Unfortunately for us, this was published 2 months after we started our Taming initiative, so we couldn't really take advantage of it. In hindsight, it would have been an invaluable source of knowledge because it identifies 40 adoption problems for continuous delivery and summarizes them in 7 groups. And as I mentioned previously, most of the other articles on the internet are referring on how to implement continuous delivery and not about the problems that you might find. But as I also said, we couldn't use this as a reference, so instead we organized a lot of sessions with the teams that were working on the web shop. And we identified 11 problems that were actually problems for our use case, and they were all listed in the paper. That's why I said it would have been an invaluable source of information. And now I'd like to focus on the problems that we in particular encountered. The first and most prominent one was the flaky and unreliable tests. I don't know about you, but I've seen a lot of companies where people start neglecting their tests at some point. And for this project, it was the case that over the years, a lot of the tests became flaky or unstable. And there were some teams that would not look at the test at all and would do manual verifications for the parts of the web shop that they maintain. And you can imagine that if you want to release more frequently, you can't really ask people to do this manually every time. The way we solved this was actually by taking a quite radical approach, in my opinion, but we also agreed that there is no other way. What we did was we started with a blank slate. We created a brand new suite of tests, and we added 7 tests that were covering the critical functionality. We quickly expanded that to over 200 tests, but on the premise that every new test that will be added to the suite will actually be stable and reliable. If we identify the test that is flaky, we would either replace it or try to fix it. Or fix it, no. We, otherwise, we would just remove it and try to rebuild it in a new way. The test suite resulted in a very binary feedback about the state of our release. In essence, if the tests were good, so was the release. But if one of the tests is failing, then the release is not good to go either. Rebuilding the test suite actually solved one other issue, and that's the time-consuming tests. Because before we start this, the tests would take more than an hour to run. But because we were rebuilding most of them, we also had the opportunity to introduce new technologies and effectively make this a lot faster. I think they currently run for around 20 minutes. Another consequence of creating the new test suite was that teams started collaborating a lot more with each other. Maintaining a test suite that is blocking your release can be very demanding, especially if you have over 70 engineers working on the same project. And in order to achieve that, teams had to work together and collaborate more, which set the grounds for solving another set of problems, namely the lack of discipline, the lack of motivation, and the lack of experience. Before we started this, a lot of the teams that were working on this project would consider it a no man's land. And they would solve their own problems in their own specific way, and they didn't share the knowledge between them. That resulted, as you can imagine, in very poor code quality, and in some cases, reinventing the wheel for problems that were already solved. For me personally, this was a very good example for the broken windows theory as well. And for those that are not familiar with the broken windows theory, it roughly states that if you have a building or a car with one broken window, there's a lot higher chance that people will break more windows in that building or car or other parts of it. In contrast, if everything is intact, people are far less likely to break anything. And you could translate that very well to code, where if you have a code base which is full of code smells, people are far less likely to adhere to higher coding standards there. And there were teams that would exemplify this very well because their services would be very well maintained. They would adhere to very high standards for their services, but whenever they were working on the web shop, they were very likely to take shortcuts or not necessarily implement everything in the best way because the code was already smelly anyways. But with the focus on fixing the test, the team started collaborating and started sharing knowledge. And eventually, that spread to all parts of the system and not just the tests, and resulted in overall higher standards and higher expectations of the code in the web shop. And actually, people started solving problems that have been known for ages, mostly because now they had the expertise or they knew the people that had the expertise on how to solve them. The next set of problems that I want to discuss can be summarized as a poor branching strategy, or in our case, inconsistent branching strategies. As I mentioned previously, a lot of teams were working in their own little bubble and were solving the problems in their own way, and branching strategy was one of those things. And you can see that some teams would not use a branching strategy at all and directly push to master. Other teams would identify a feature and create a branch for that feature, and once they were done working on that feature, would merge it back. But there were others, which in my opinion were the most problematic ones, that would work on their team branch for the entire 2-week period, and when we're preparing the release, would try to merge that back into master. Now, if you have one team doing this, I guess it's going to be okay. But if you have 5 or more teams doing it, then it becomes really difficult to handle. Mostly because if you have so many branches that are diverged and people are working for 2 weeks on them, then merging all of this together resulted in a lot of merge conflicts. And people had to spend a lot of time resolving those. There were cases where this would lead to days of delay. And the way we solved this was by introducing at least a consistent branching strategy. we decided that we're going to go for one branch per feature. And for us, one feature, we agreed that one feature would be one Jira story. So whenever you start working on a Jira item, you would create your branch, you would work there, and once you're done with it, you would merge it back into master. Of course, this worked very well for us, but it's important to know that the paper that I referred previously actually suggests not using a branching strategy at all for this use case. Because if you work only on master, there's a lot less chance that you will get a lot of merge conflicts. But in our case, this made things a lot messier. So you have to figure out on your own what's the best thing. Another thing that helped us a lot was that we actually put this monolith in a container, and we made it work with an internal platform called Mayfly. And Mayfly does a lot of those things that I mentioned previous for you. So whenever you start a Jira story, it will create a new branch for you. It will create a new environment for you. And also, one of the best things, in my opinion, was that every time something would be merged back into master, it will try to rebase your branch, thus keeping it up to date. And I hope that everyone that has worked with Git knows that the best way to avoid merge conflict is to keep your branch up to date. This resulted in a lot smoother ride in terms of source control. We had a lot less issues when merging new features, and actually spending the time automating all of it paid off in the long run, because everything that Mayfly does for you, you can do manually as well. However, automating it, putting the time and effort to automate it, saved the developers a lot of time. And they could focus on working on the features rather than merging or rebasing their branches. The next set of problems can be summarized as simply lack of visibility. For any project, in my opinion, it's important to have visibility of what's currently in your pipeline, but for a project at this size, it was vital for us to do it. Because if something goes wrong with your release, and you start searching for what the root cause might be, if you don't know what are the changes that are currently in your release, it's really difficult to figure that out. The way we tried to solve this previously, before we start this project, was that someone would create manually a Git diff between the version on production and the release candidate, put that into Confluence, but the moment someone applied a patch to the release, then this list became obsolete. And because not a lot of people knew about it, it was never maintained properly. Unfortunately, there's no universal advice on how to solve this. For us, what worked very well was to create a small service that would get the versions from the different environments, then create a a Git diff, and visualize it in a nicer way. Another thing that helped us a lot was that we enforced a policy where you have to include your your Jira item in your commit, and that helped us group commits by features, and it was helping it a lot. It was making it a lot easier for us to track which feature is on which environment. This service helped us identify easily what were the changes on the different environments, and if something would go wrong with the release, for instance, one of the tests would be failing, it was very easy for us to start looking for the culprit, to see which part of the code might be causing this problem. Another thing that happened was that this service evolved into something more, and we currently use it to track the progress, or actually the status of the features. So you can mark your feature as good to go or not. And we're hoping that with this, we can actually bring this to a step further and adopt continuous deployment. Because if all your tests are good and all the features are verified, then you can easily and automatically schedule the deployment rather than doing it manually. So at this point, if I was in the audience, I'll be thinking, these guys did it so smooth. They solved everything with no issues. It just sounds too good to be true. And in reality, it is. But we also felt that everything went so smooth. We were really happy that everything went so well. But the moment we started doing more frequent deployments, one of the problems came back to us. We were so focused on fixing the tests, and we were so focused on keeping those tests green that when we started deploying more frequently, we kept that focus on the tests. But because of that, we failed to communicate properly that we have made changes to the development process. So not everyone knew that we had a new branching strategy. Not everyone knew that they could use Mayfly. And this resulted in some people still treating that project as sort of a no man's land and working with the old, like how they were used to. Um, and actually, there was a case where someone pushed changes directly to master right before we schedule a release, which broke the flow for everyone and resulted in a snowball of issues that made us rethink whether or not we should postpone the whole initiative. Luckily, we managed to push through and fix everything. And after that, we organized another set of sessions with all the teams that are working on the web shop to show them what is the new branching strategy, how they can use Mayfly, and how can they make this work for everyone. So we put a lot of work into this, and we wanted to see if it was actually worth it. So we measured the first 8 weeks after we started more frequent deployments. And we analyzed that we had 30 releases instead of the 4 that we would previously had in the previous flow. And we had released 447 features, which I'm not sure if that would have been the case with the previous situation, but now we had the tools to accurately measure how many features have been released to production and where they are in the pipeline, which I think is pretty cool. And finally, the average time for a feature to go to production was approximately 4 days, rather than the 1.5 weeks that we had previously. But seeing the benefits of this initiative, we thought, how can we bring this further? How can we make the future of our developers even easier? How can engineers work in a more streamlined way? And inspired by Facebook's release strategy described in this blog post, we're actually working on a service similar to their Gatekeeper. I'm not sure how many of you have heard about Gatekeeper, but essentially it's a feature toggle service, which allows you to turn a specific feature on and off without having to redeploy or restart your application. It's a very common pattern not used only by Facebook, but also companies like Google, Slack, Dropbox, soon Bo.com as well. And if you're curious about feature toggles, Martin Fowler has a very good article explaining all the different types of switches that you can use, and actually has guidelines on how to implement them as well. For us, implementing this service felt like, huh? Why haven't we thought of this earlier? Because it would allow us to deploy a lot more frequently and without having to worry about the features. The only thing you have to do is turn a feature on and off after you've verified it, but you decouple that process from the actual deployment. And to sum everything up, here are the main lessons that we learned. If you want to implement continuous delivery, especially on a large legacy project like ours, what you need to do is you need to have a stable and reliable test suite. For us, this solved a lot more things than we expected. The next thing that you really need is stable and reliable test suite. That binary feedback about the status of your release is something that once you get, you never want to lose. Another thing is that you have to choose a proper branching strategy that works very well for you. As I mentioned previously, it can be different than the one suggested, or it can be no branching strategy at all, but you have to find something that works very well for you. And if everyone adheres to that branching strategy, that would result in a lot less merge conflicts while you're working on the project. Another thing that's very important is having visibility on your pipeline. If you work with a team of 5 people, it can already be difficult, but I guess you can easily track what's currently on the different environments. But the more people you get on board and more people working on this project, the harder it becomes to track what's currently on the different stages. For us, a simple git diff visualized in a nicer way did the job, so it doesn't have to be some rocket science or something out of this world. And finally, you have to have effective communication. Again, if you're working in a team of 5, then it's really easy to communicate the changes that you're making to the development process. But as was in our case, having more than 70 people working on the same project, it's really important that you have an effective way of communicating any changes that you're doing in the development process. And finally, if you think that this took a lot of time and a lot of people to do, it was actually 5 people, and we did it alongside our day-to-day responsibilities. And it took us, I think, around 4 months to facilitate and to build all the tooling around this process. With that, I'd like to thank you, and I think we have plenty of time for questions. Yes? Yeah, thanks. Yeah.
How did you solve feature toggling? I mean, how do you enable and disable it on the implementation level?
Are you talking about the feature toggle service?
Yeah, yeah.
So for now, it's just going to be a on and off. There are plans to start doing it for. There are plans to start doing it per server, so you only enable it on a specific server. But we don't really have plans right now to do something like a canary release or just transfer just a percentage of that traffic. It's something that we're thinking of, but not really working on implementing right now.
Okay, the question actually is about exactly implementing it. I mean, for example, if you have 10 teams working on the code base, and they are releasing multiple features per sprint, it means that 1 or 2 releases may contain up to 20 or 10 multiple features. And also,
I see what
probably you want to keep that feature enabling for multiple, let's say, releases. Not because if you release every day, you may want to disable it like week after.
So if I understand your question properly, actually the feature toggle service is going to solve that problem for us. It's more about how do we avoid stacking a lot of features in one release, right?
Okay.
Or
I mean, I'm more interested in how this service is implemented and
how the service is implemented. Then maybe we can catch up afterwards, and I can tell you more about the service in details.
Yeah.
Yeah.
What kind of test did you focus on first? Did you focus first on integration?
I'm sorry. Can you? I don't have a set. I don't know. I don't have a set.
Doesn't
So
work?
everyone else can hear, but I can't really. No, can you just say it a little bit loud? Okay, yeah. Thanks. Yes, we got this.
So I was saying, what kind of unit test you focus first on? The integration test or unit test or UAT, or what kind of test do you focus first?
So the test that I was referring to in that particular section, the tests were mostly integration tests. The unit tests are part of the build, and I think they take around 15 minutes, including the build time. So maintaining those was actually we did a lot of refactoring there as well. But in this particular initiative, we were more focused on the integration tests because we wanted to make sure that the website actually works and not the individual units. So there were teams that were focused and had focus on actually fixing the unit tests as well. But in this case, it was mostly about the integration.
So in this case, how did you create? What kind of architecture you create to run this integration test? Did you have a Docker, Dockerized setup on a Jenkins environment, or what kind of architecture was it?
For now, it's running in Jenkins, and I don't think they're Dockerized. We have a separate environment which is for the release candidate, and we run a lot of integration tests against that environment. So I hope this answers your question. Yeah. Okay.
have questions about regression bugs after switching to continuous delivery. How much increased the bugs that are not tested and go to production?
Well,
Regressions. And
that's a good. I don't have a definite answer for that. Um, the fact that we're still doing this means that the tests are actually the problems that we encounter are a lot less. It's important to note that we decided when we started this that the moment we find an issue, we would roll back immediately because we knew that the previous version should be stable. We had a lot of cases where bugs were introduced in the past and we had to fix forward. But normally we would, whenever we identify the problem, we would roll back. And because we didn't have to wait for the 2 weeks release cycle, it was very easy to convince all the stakeholders that we're just going to roll back, fix it within the day, and then redeploy on the next day. But I don't have a specific number on the number of bugs that we...
okay, and so you deploy it, and QA find an issue during the day or something like that, and then you roll it back and fix and deploy again.
Yeah.
Okay, okay. But the number of issues that are coming has been more or less?
I don't have an accurate answer for that, but
Okay,
I think
so-
on average it's pretty much the same.
Okay.
Well, of course, if you deploy more frequently, there's a higher chance that you would get more releases, but because the delta is so much smaller, it's a lot easier to identify them and fix them. So there's always a trade-off.
Okay, thank you.
I think there's... Oh, sorry.
There are two ways that using which we can do, I mean, either trunk-based development or feature-based development. So which one is good? Is there any like advantages of doing trunk-based development over feature-based development?
Well, as I mentioned, it really depends on your specific application and the team that you're working for. In our case, working on feature branches actually helped us a lot because we could also have a separate environment for that feature and we could test it in isolation. But if you want to reduce the number of merge conflicts that you have, then as the paper states, you can just do the trunk-based development and directly push to master. So it really is something that you have to figure out what works best for your project. Both have pros and cons.
Okay, thank you.
As you are deploying multiple times a day, are you using something like Scrum or Kanban? What's your process?
So a lot of different teams have their own independent way of working. Some teams use Scrum. It's very popular in the company. Other teams that are more working better together with using Kanban. So different teams work in a different way. And the process is actually independent from the release process because different teams are contributing to the project and they do it within their way of working, which is kind of independent from the release process. Oh.
Thanks for your talk. I have a question about database changes. So let's say you have to update schemas. How do you handle that in a continuous delivery pipeline?
Yeah, I love that question. We were lucky in this regard because this project the database development has been frozen for I think 3 or 4 years now. So we didn't have to tackle this particular problem. For other projects in the company, what we normally do is we have a separate project for the database migrations, and you make sure that all your data. Well, there are some cases where you cannot really do it, but you do forward compatible and backward compatible changes. So your database should be able to work both with the old and the new version. And it's sometimes really difficult to do, but we try to do it in a similar. Sometimes when it's inevitable, you would bring a service down, run the migrations, and then restart it with the new version. Okay. So thank you, everyone. If you have further questions, you can come here. And if you're interested in all the articles that I referred to, you can find them at the end of my slides. Thank you.